this time with a different type of modulation. Mainly the theme of this is the quantum modulation. And I don't think I need to explain much about this lab because you already know Hilbert transform from doing the SSB. It's just this time we're not doing SSB, we're not doing single sideband, we're just doing the Hilbert transform. And you can use the formula, you can use the direct formula for that, or you can use the signum function in MATLAB. You can use the sine function to construct the SSB. Either one is fine, all right? So you can use this function, which does Hilbert transform again. And I just want to bring you one thing. If you didn't use this for SSB for lab 2, then you might want to look at it. So the output of here, X is Hilbert XR. XR is your input signal, and then there's X, that's your output, is equal to XR. This is the same XR as this, plus I times XI, which XI is the Hilbert transform. So in here, the only Hilbert transform is the XI. Okay, Miguel, just explaining lab 3. I don't have any new concept to show, so like I'm not going to record anything. So just going through the whole gist of lab 3. Like no new concepts in lab 3. So I won't be recording this. Yeah. So Hilbert transform. So learn how to use that, and if you find the direct formula to create the Hilbert transform, like the signum function, then you might want to do that as well. Preferably, you can do that, and you will understand more of how Hilbert transform works. So, yeah, in a nutshell, Hilbert transform is just take whatever signal you have and then phase shift it by 90 degree. What that means is that when it detects some like abrupt jump, like in this function, when it detects an abrupt jump, it will note the Hilbert transform will have a sharp spike to that as well, to denote that this is a huge jump. So if we delay the phase of that thing further, it will jump further, and that's a kink right there. Okay, should be able to see it when you do the Hilbert transform. So that's one. So there's only two function here, 1 and 2. And then for number 2, we plot the spectrum of the Hilbert transform using MATLAB, and just do the usual FFT routine of these two and the Hilbert transform. Okay, that's the xi over here that you get from using the function Hilbert. And then quantum modulation. So I'm pretty sure on Tuesday, Dr. Kwan discussed with you quantum modulation, and so a little bit into maybe frequency modulation. But now we're just doing quantum modulation, which is 2-branch, sine and cosine. The reason why we do a sine and cosine is that we can send like two signals instead of one. So for the usual modulation, we only send like one, like sine or like a message signal and multiplied by a cosine carrier and broadcast, and that's it. For these two, we have a branch. Okay, I'll show you a little bit when I finish this. Okay, so quantum modulation, there's a scheme for it. It's very easy to do. There are two carriers, like I said, there's cosine and there's then sine. There are two message signals sending, and we send them simultaneously. Okay. And then you're going to plot the signal M mod. M mod, if you look at the diagram, is the summation of M2 times the carrier of times the second carrier plus M1 times the first carrier. And then you're going to plot that in the frequency domain as well. For quantum demodulation, so it follows by the demodulation process again. So the receiver will also be consisting of 2 branch, whatever the original is multiplied by, like say the carrier, in the receiver will multiply by that carrier. So if M1 is multiplied by C1 and it's broadcast in the receiver, that same thing, if you want M1, that sum here, if we want M1, that sum here must be multiplied by C1 and then followed by a low pass filter, which you will use the techniques I showed you in lab 2 to design the filter for this lab. Okay, same thing as well. And the second branch, C2, will be multiplied by this sum to get the M2, okay, and filter as well. So you need two filters. Actually, if you keep in mind that you design your filter well that suits both, you can use just one filter. You can use just one filter. You can have one .mat file, or if you no, you can have one .mat file, and in that .mat file, you can have two filters, one for M1, one to filter M1, and one to filter M2. But if you determine, and this is up to you, if you determine that filter for M1 can also be used for filtering M2, then you can just use one filter. Okay, it's up to you, whatever you feel comfortable. All right. Yeah, same thing from here. Okay. All right, any questions before I show you a little bit more about quantum modulation? So far, okay. Yeah, this lab, as soon as you're done with lab 2, this lab will be very easy. Okay, share screen here.